Welcome to DACM Insights. This is a podcast where we bring interesting institutional grade crypto projects to institutional investors to hear about the exciting things happening in Web3. We think this space is still the most exciting, highest growth tech that there is in the world. So it's our pleasure to bring some of the founders that we respect and invest behind to present to you the businesses that build in and show you the real things that are happening in crypto. Hi everyone. I wanted to welcome Greg Osuri to the podcast today. Greg, thanks for joining us.
Richard, good to be here as always.
Greg, we met many years ago when Akash was starting to raise capital, and we were lucky enough to invest. And you were someone that came to us with some pretty out there ideas at the time. You know, crypto had just started to get some little amounts of tractions around DeFi, and people starting to get excited about how smart contracts could be used that way. And suddenly we get a pitch from a guy that's telling us that he's going to use core parts of crypto to build a capability that allow us to scale compute at a faster rate. And we're kind of like, wow, this is pretty impressive. So with that in mind, it'd be good to understand how you got to that position. What had you done before the idea of Akash came along, and what was the key genesis to get you to start sort of building this project?
Yeah. It is funny because I saw a Twitter thread yesterday. People talked about, there was a question about, hey, how has crypto benefited humanity besides Bitcoin? And somebody
I saw that
commented,
same one. I saw that.
oh,
Oh,
yeah.
yeah.
Somebody commented, basically said it led to the entire infrastructure creation for AI as a side effect. I'm like, well, you don't really think about it without crypto. You don't think about all these unintended sort of like benefits you get. You only think about the direct benefits that are in line. But, for the most part, the data center build out that AI demanded in 24 was satisfied by crypto companies, like it or not. So, um, at some point you'll start seeing crypto and AI, all these technologies just energy distributors, like load balancers, I call it. When I looked at crypto, crypto was met my eye in, I would say like 2012, 2013 plan, with Bitcoin in making waves, and anyone in tech, anyone on Hacker News would see Bitcoin in headlines pretty much every other week. We did not start off with crypto. We began, my background, I've been an open source developer almost all my life. Particularly in the last 20 years, I've been focused on developer um, tooling. I would say like since 2008 onwards, I was exclusively working on cloud and scalable systems in San Francisco, working with several high growth companies and Amazon Web Services, which is the cloud unit of Amazon, the most profitable unit of Amazon business, which actually serves other companies and provides the cloud services. It was 2013, I would say, was Amazon glory days, right? It's like how AI is right now, Amazon was that, right?
Yeah.
And the big product Amazon Web Services offer is peace of mind and convenience, which is great if you're an enterprise company and if you want to pay somebody and to take care of your infrastructure, Amazon's fantastic. But as you try scaling, the comfort quickly becomes intense think, right? And it gets very inefficient because all these services that are supposed to make your life simple uh, will nickel and dime you. So uh, in 2013, it was also peak open source, I would call, right? So we were talking about incredible projects like Kubernetes, Docker, all these projects that define infrastructure today were getting their genesis here at that time. So I was deeply involved in this ecosystem. I've written several libraries and that are actively used by Kubernetes. Kubernetes today is used by 80% of the cloud. So 80% of the cloud uses my code somehow. So through these the contributions I made early. And there was this general notion amongst the open source and the academia communities that, hey, look, cloud is getting increasingly more important in our life, and it's also getting increasingly closed source. Meaning all the success that we had with open source software, be it databases, critical infrastructure, like most infrastructure today runs on Linux. 97% of the web runs on Linux. So web really took open source to of the mainstream. The Google's, I guess open source or whatnot. But then we see cloud coming and like taking that away, right? Because cloud is increasingly getting closed source. So that was I would say, a situation most people were not not liking it, especially in the open source community, and they wanted to do something about it. So there was research from Cornell talked about supercloud. The idea for supercloud was like, look, there's a lot of compute out there. Uh, Compute in universities, here in office building, homes with various degrees of reliability. What if we create a cloud that can aggregate the compute and leverage the underutilized compute? Like at any given time for a web scale company, underutilization is 95% on an average day. And the reason for that is if you're a web company where you're serving customers all over the world, it's very hard to predict load, especially when you have seasonal loads like e-commerce or taxes or whatnot, right? You have certain months of the year extremely busy or certain days of the year extremely busy, as most of the year you're not busy. That's how Amazon web service got started because on Black Friday or on the Christmas season, you have enormous, traffic. Being off season most of the year, you don't have too much traffic. So Amazon bought a lot of servers, in the .com 1.0 boom, which has a lot of parallel to today's like world. And because people were like, hey, everything's going to be online, they need a lot of data centers, a lot of fiber that was laid out, called it dark fiber back then. And then they quickly realized that look, the .com crashed and all this demand they thought they had was not exactly how they intended to be, but it turns out leveraging their underutilized capacity and creating a cloud actually was way more profitable. So Amazon started on the very premise, the Amazon Web Services, that we can leverage underutilized supply. So we took the same idea. We're like, well, why don't other companies do it, right? Like, every company has underutilized supply. And that gave birth to Akash Network. And when we wanted to do it, we wanted to keep it open source. And fortunately, in 2015, some engineers I respect quite a bit showed us Ethereum. Ethereum, I like Bitcoin. The idea had some Bitcoin back then. With Ethereum, Bitcoin was fascinating, but Ethereum was even more fascinating because it's Bitcoin programmable. That's how I understood Ethereum. So we went about playing around with this technology. It solved several critical problems with scalability, not the blockchain itself, but the scalability of the cloud, right? Because it made node membership super permissionless. It made a lot of problems to scale traditional very simple to solve. Granted, it's not the most efficient database, but we're not looking for an efficient database. We're looking for, we were looking for a permissionless program, right?
Yeah.
Pretty simply by removing all the buzzwords and extremely critical for infrastructure. And it solved the problem, and we thought it was very promising. We got a white paper in 2017. We got a lot of this around the same time. Filecoin did the ICO, and there was a lot of excitement in the community. What Filecoin did with storage, you can do that with compute. And that was the genesis of what's the deep in today, right? The entire category was created. Now, if you look back, that was the moment we got started.
I think when looking back on how we saw Akash when you first presented to us, we were like super interesting idea. Use cases at that point were relatively thin on the ground in terms of the use case of mass compute. You had crypto, to your point, Ethereum and those sorts of GPU driven blockchains back then using a bunch of compute. But apart from that, some CAD programs, some other type of media type operations. Did you see the dramatic rise that has now since come in terms of the load of compute the world now consumes? And I know you've spoken to Congress about the energy crisis is sort of leads, but are you surprised at where we're at today? Or did you see that we would get to this sort of scale this quickly? And where do we go from here?
I was not surprised at it, but I was surprised at the time. I thought we had more time to get to the scale that we have right now. What I meant by that was it was not surprising to me when you talk to AI people, customers on the ground. I think I remember very clearly talking to you back then. We talked about some of the customers, AI customers in 2020 that were complaining about costs. And we started looking into it. The cost for running AI back then was not just GPUs, it was bandwidth storage because AI takes a lot of storage. I mean, look at memory. I mean, now we're starting to see memory being priced. It's funny because people were complaining, AI folks are complaining about memory because the models and you need to load them into memory and you need a lot of memory for that. So we started looking at, different AI companies, and it was very obvious. Akash was a perfect fit. So it was not surprised to me that we led or sort of created this whole like crypto AI space, right? But what was surprising to me was the scaling loss. And I think that's surprising to like a lot of folks. It really began with Transformers 2020 in Google. And then for the first time since 2020, and I play around with GPT-1. It was kind of like basic and it was kind of creepy in a way. The first like stable diffusion models or diffusion models, if you remember, the like weird AI created like creepy like images. I mean, you couldn't quite see from the outcome, you couldn't quite judge the quality, but you could see eventually you get improved. My timeline was much further away. I didn't think it was going to be 23 in any way that we're going to see this boom. I think what happened was as scaling laws became clear, the risk got lower. What that means is, uh, for the first time, you can actually throw a bunch of compute in AI, and you can actually see the quality of AI improve. Like GPT-1 to GPT-2, GPT-3, it's just more number of parameters that means more amount of data, that means more amount of chips that you throw, that means more energy, and you just end up getting a good model. Now, the scaling laws are sort of like, you know, being challenged now. Is no guarantee that more compute is going to just give you better models. It's going to be like different architectures. But I think after scaling laws became very obvious, and it became very obvious to us that, hey, we need to really source supply. And it was not obvious to the world because unless you understand what's going on with the transformers and scaling architectures and all that, there's really very little to know. But that was our advantage, right? We were able to uh, you know, uh, kind of educate our crypto people on this. Hey, there is a shortage of GPUs. There's no amount of GPUs in the world. We looked at NVIDIA's production lines. NVIDIA was making, in 23, they made about 500,000 H100s. And we needed about 4 million H100s from the demand. So there was clearly, it's very obvious. When you go to Amazon, there's no H100s or A100s. You can't get them. So there was such clear, obvious need that basically defined what 2023 and 2024 was for Akash. And of course, that led to a lot of, with crypto, there, then you end up with a lot of folks trying to replicate and trying to copy Akash's codes and launching clones. But at the end of the day, we survive and we still are the innovators and we are still our leaders. And now we have more crises, right? I mean, GPUs were just the tip of the iceberg, turns out. Now we have memory, now we have storage, now we have energy, which is a big unknown. I mean, it's clear to me, I think, how we can solve the energy problem, but it's unknown for a lot of people to solve.
Yeah, Greg, that's one thing I wanted to touch upon. I mean, skipping a little away from core crypto discussion, which I'll come back to. I know you've been vocal around the energy crisis you see coming driven by AI. I mean, we've spoken just about, it's one thing to scale technology at certain speeds. It's another thing to scale poles and wires and generators, right? And I think that's what the world's finding out. Now, I know you've spent a lot of time on this and been very vocal on the energy crisis. Can you run us through how you see that playing out and some of the, I guess, the energy needs you see as we sort of project forward the next 5 years? Yeah, and you spoke a little bit there about some of the solutions to the problems you're raising partly involve decentralization, like the installation of solar on residential properties to effectively push the generation out to the user. Bringing it back to Akash, how does decentralizing the compute task solve the problem that the hyperscalers can't?
Yeah. So you gotta ask, why do we need so much compute, so much energy, right? As a function of compute. The reason for that is, so in AI, there are two main types of applications. You have the inference and you have training, right? Inference is when you survey AI, so when you go to ChatGPT and you ask it a question, that's inference, right? Inference is in order to infer a model, you need one GPU per one prompt, simply put. So every prompt you send is actually that, and it takes 10 seconds to return the answer. That 10 seconds is being computed on one GPU, right? Now you can do parallel, you can do all kinds of things, but just at a high level to get things simple, think of it that way. So if you have 7 billion people in the world, if everybody's on AI, you can imagine how many GPUs we need. Let's not go there yet. If we're talking about 7 billion people using AI all the time, right? Now we go to training. So the way training works is we as an industry, as a distributed training landscape, are maybe at a GPT-2 level in terms of our technological progress. So we need to be at GPT-4 level to be state of the art. And that's going to take some time and some resources and incentives, right? Like the big question is not, the technology is very, very promising. We're able to build bigger and bigger models. Now the question is, what is the incentive for someone to provide the compute to train a bigger model? What am I getting back? Like I have a 4090 at home, I have a 200 at home. I have solar at home, for example. I can totally use my solar. My marginal energy cost is negative right now. I mean, the California pays me more than I pay California from energy costs. But I love to use that for a better purpose, which is California doesn't pay much and they nickel and dime you for solar. But if I can use that same solar to power a GPU from a home, while the distributed training is solved, there has to be some incentive. And I think that's where we're entering in crypto AI space. And where Akash fits in, Akash is the infrastructure layer for the entire thing. So Akash has home nodes. I mean, sorry, not has, will have home nodes. We're introducing the program. We talked about it after my testimony at Congress. I talked about leveraging home networks as part of a training run. In order for us to achieve that, of course, there's technologically challenging like problems that we need to solve. And I think we solved the networking problem. And we're calling it the home node. I have home node 1 at my house that's going to be online by end of the month. That's why a lot of work is happening on the background. It is a little energy intensive. I mean, at least the first version, it does take quite a bit of energy, but hopefully in the next coming versions, we'll be able to reduce the energy footprint to a point I can have one single panel or 2 panels power a training run. Right now I have 60 panels that are powering a training run, which is, it's not bad. So our solution to the problem is if you can distribute training, you can tap into a distributed grid. It's not like we don't have enough energy. We have a lot of energy. It's just we cannot transmit them well. We cannot do it at a utility scale. But solar is fantastic when you have a residential scale, particularly when you have dual purpose. In the sense that I use solar to power my home and excess energy, which I always have a lot of excess energy, depending on even California winter months have excess energy. What do I do with the excess energy? I can train AI with the excess energy. So AI becomes now a load balancer for energy, which is a great solution to problem because the grid don't want to take your energy because, again, like I said, grid is very fragile. So California will, at least the utility companies will stop you from producing more energy because they cannot transmit that. And if you try to transmit it, you break the grid. So the lots of checks and balances for how much energy you can produce at home. But AI can solve all these problems for us.
You spoke, I mean, Akash is in the interesting position of your ideas being proven perfectly correct, right? You've built a product, the market that it serves is probably growing ahead of everyone's expectations by quantums. You've got a lot of experience under your belt now, right? Like you've been in the wild a long time running a network. You've got a big use case that's been delivered to you, ready for you to monetize in some way. You've spoken about home nodes. What are the other next steps that Akash takes to really make sure you make the most of this opportunity that you've worked a number of years to be in the position to monetize?
Yeah. So right now for our offering and our value that we offer, we have a strong case and demand is growing, all the good stuff. But now it's time to scale, right? So like we have proven our product, we've proven the market, we have decent revenues that are consistent, we're able to repeat, really good customers. We have all these like fundamentals of a business that are working really well. Now the question is, how do we get to all the demand that is being generated, right? Like, so there are several things we need to get there. First, from a capability standpoint, we need to be a little bit less specialized and more general purpose. What that means is, if you go to the cloud today, you have multiple Amazon Web Services or GCP. You have multiple ways you can deploy something, right? You have this flexibility where it could be a big enterprise, a Fortune 500 company, they can use Amazon Web Services. Or it can be a startup, it can still use Amazon Web Services. The wide range of flexible options makes it very, very attractive for users. So that's one thing. Second thing is just sheer amount of compute scale, right? How much available compute there is on Amazon's world, becomes very attractive, especially if you're a growing company and you want some guarantee that, hey, you will pick a cloud provider, they're going to serve your needs through and through all the way till you become a super large company, right? And third thing, I believe is this unique value proposition. I think that we have kind of nailed that problem, right? We have our unique value proposition is well, we can go places where cloud cannot, like homes, for example, or office buildings or academic, or universities where cloud just can't go there. Their model doesn't quite fit. So we have that going on very, very strong for us. That presents a different challenge. The challenge is quality, right? Because now every computer is by its own and there's no control so the network doesn't control the computer. It is the person that, owns the computer really is responsible for quality. And quality could mean internet quality, could mean, are they giving you enough energy? Sometimes, when you're running GPUs, you can run them at 80% GPU, 80% energy, because if you're running 100%, you want to blow your bill. So a lot of these like quality assurance, quote unquote, needs companies look for when you're choosing cloud. So our area of focus is all three in terms of just product standpoint. First is we're adding new capabilities, traditional capabilities like virtual machines, privacy, core privacy in terms of like trusted execution environments. Don't want to get too deep into the roadmap. A lot of the items on the roadmap are to serve bigger enterprises. In fact, we're really announcing a few big enterprise customers hopefully this quarter that are looking into Akash and are fascinated. We're doing a bunch of POCs. These names you'll know pretty well. But that will be definitely a cosmic chasm moment for us. Now we're looking for small enterprises or mid-sized enterprises to larger customers, right? So we design a system we believe is far superior than any system that's out there, but that specifically addresses retention and volatile market conditions. So this is on-chain verifiability, and no one has cracked this nut yet. Verifiability will allow us to tap into more compute with lots less trust needed, right, than the auditing system we have today. So a new system will combine quite a lot of this stuff that we already have, along with newer verification technologies, right? And third is quality assurance. Like, how do you ensure like you're getting good quality? And I think through verifiability and privacy, you'll be able to leverage quality control, or provide quality control rather, right? So we're excited. I mean, I think scale, all three comes down to scale, right? How scalable you can get more capabilities, and more verification of those capabilities is our big year's focus.
And when you look at, I mean, it's a great roadmap, and it's a way to, I guess, the project's persistence of being around a growing market for this period of time and getting it right and monetizing that. You talk to a bunch of investors about that. What's the biggest misconception about Akash that you want to address?
Misconsumption or Akash? Oh yeah, people think it's a GPU cloud, not the general purpose cloud. I mean, a lot of things over the years, right? People forget that we've been there for a long time. Maybe because people heard of us in the recent past. We were never like the mainstream cryptos. We've been around since 2017, but we're not smart contracts. We don't have, DeFi. We don't have NFTs. We don't have any of your traditional crypto, I guess, those people are looking for when you talk about crypto, right? I mean, even though there's a lot of pressure, if you remember in 2017, you were not there in our first fundraise, but 2017, 2018, we did our first small round. And we would go to investors, and everybody would be like, "What? You don't have smart contracts? Like, what are you even here for? What are you doing?" Like, no, we don't have smart contracts. We're a general purpose cloud, and nobody would care. 2020, things started a little bit better when we did before our launch raise. And people were like, "Okay, well, you don't have smart contracts. You have compute. There's a market for it." People like you could see the light, and of course, good investors could see the light, right? And I think in 2020, we were like talking about GPUs briefly. We're talking about AI companies for sure. Just starting to talk about GPUs. In 2023, it just became very obvious. GPUs are going to define this era, right? And we had millions of people raising hundreds of millions of dollars now to build Akash competitors, right? It's kind of crazy how this landscape blew up. So biggest misconception I think people have about Akash is, well, we pivoted to GPUs. Now, we did not pivot. We began long time ago, and GPUs were on roadmap, and people didn't pay attention to roadmap. That's not my problem. Number two, people think we're a GPU-only cloud. We're not GPU, we're a general-purpose cloud. And people think, verifiability is not a reality in general-purpose cloud. It is possible. It's just you never saw this version of verifiability, like you never saw the version of crypto, right? And then also, I think people are very hype and market cyclish. Like they look at right now, when I look at market, we talk, I was in Singapore, for the conference, and that place where we one of those the side events we were at with the investor stuff, it's all about stable coins and regulatory arbitraging right now. Because US opened up the doors. Everybody wanted to be in US. Because the regulatory arbitrage is the first mover's advantage, right? And nothing else. Like AI is dead, DeepN is dead. DeFi maybe, unless you're in stable coins, nobody cares unless you're in DeFi. Aave is shown signs of life. But pretty much crypto is dead. NFT's gone. Nobody talks about them anymore. Memes gone, thank God. But and people say crypto AI is dead. I'm like, well, no, we're just getting started. All the junk is gone. That's supposed to happen. That's part of, part of market cycles, you're going to see a lot of capitulation, and that's good. But I think the next version of crypto AI is going to solve distributed training, and it's going to solve distributed training in such ways that you would never see it coming from a million miles, right? It's going to hit you hard. And now I think it's a great time to be an investor because now you see it's a lot of signal. In 2014, so 2024 was too noisy, and I just didn't like what I created. I suppose the whole like category. There's so much fraud. There's so much um, grifters, right? I mean, it happens all the time, and you see some success in crypto. Everybody wants to do a GPU cloud and everybody was. I mean, I'm pretty sure 90% of them had Akash didn't do X, Y, Z. Trying to like build another Akash, right? So it happens a lot, but I think because we have a clear vision of where we're going, we're not following someone else, right? We're not, I'm not. There's no other Akash that I'm like trying to clone, and we see very clearly the energy is a problem. Not only energy, memory is a problem. You see super micro, the micron stock. You see a SanDisk stock, 1,000% gain or something in the last 1 year. I mean, what does it tell you? I mean, it's just all the demand from AI, the memory demand, is just starting to hit so hard that you have to ask yourself the question, like, don't we have enough memory in the world? Like, are you kidding me? My fridge has more memory than my computer that I had like 15 years ago, right? Like every TV has so much. There's so much compute out there. Um, and I think with like as we progress, Akash, right? We came from data center only compute because that's the most reliable compute, now to home compute. And it was part of a roadmap because if we can make a home compute work in a cloud environment, that's a holy grail. Because now you can unlock the entire home, right? There's so much compute out there now. And I'm really excited for home node. I think like we'll be I guess graduating from just like your perception of the cloud being data centers only to perception of the cloud being the entire globe or any connected device, which is very fascinating for me.
Greg, you've been an incredible forward thinker and disruptive thinker about where both crypto and AI tech can go and how they can work together. What's the best way for our listeners to sort of follow your thoughts going forward? Where are you most active on social media? How can they stay across what you're thinking about?
Twitter is my most active platform. Greg Osuri is my handle. If you want to follow Akash, AkashNet is Akash's handle.
That's awesome. Thanks for joining us, Greg. We've covered a lot of ground from where Akash has come from and some of the exciting things that step forward. So, look, thanks for what you've built at Akash and the team's put together, and look forward to following you as you guys sort of scale now through an incredible market opportunity. So, thanks for joining us.
Thank you so much. I appreciate I'll be back.
Thank you. Thanks everyone for listening to DACM Insights. If you found this interesting, please sign up to receive our weekly newsletter, and there'll be more of these coming as we look to introduce more projects that we find interesting across the crypto space to all of you.